Welcome to this section, Spring Boot in 10-ish steps. We would want to learn Spring Boot in a little bit more than 10 steps. What are the goals of this specific section? We would want to understand why Spring Boot. You can build web applications and REST API without using Spring Boot as well. So why Spring Boot? What are the goals of the Spring Boot framework? And how does Spring Boot framework work? At the end of this section, we'll also compare Spring Boot versus Spring MVC versus Spring. I've built my first application with Spring in 2005. Spring Boot was introduced in 2016. In this section, I'll share my experiences developing applications with Spring Framework and what are the challenges that Spring Boot solves. The approach we'll be using in this specific section is to start with understanding the world before Spring Boot. How were applications built without Spring Boot? We will get a 10,000 feet overview of that. After that, we will create a Spring Boot project and we will implement a simple REST API using Spring Boot. Using 2 and 3, we will understand the magic of Spring Boot. We will understand some of the very important concepts related to Spring Boot. Spring Initializer, Starter Projects, Auto Configuration, Developer Tools, Actuator, and a number of other Spring Boot features. Are you excited to jump into this world of Spring Boot? Let's get started. In this step, we'll get a 10,000 feet overview of the world before Spring Boot. The goal is not to understand everything in here, but to get a high-level overview. How are we building applications before Spring Boot? Setting up Spring projects before Spring Boot was not easy. We needed to configure a lot of things before we would have a production-ready application. Let's look at a few examples. One is dependency management. Let's say I would want to build a REST API. In that kind of a scenario, I would need Spring Framework, I would need Spring MVC framework, I would need a JSON binding framework, I would need logging. So I would need to create a pom.xml with all the dependencies and the versions in there. So we need to manage frameworks and their versions in our pom.xmls. If you want to write unit tests, you need to import Spring Test Framework, you need to import Mockito, you need to import JUnit and manage all those versions. So that's number one, dependency management. Number two is web.xml. You needed to configure a lot of things for your web application. For example, if you wanted to make use of Spring MVC, you needed to configure a dispatcher servlet. In addition, there is a lot of Spring configuration as well. You need to define component scan. If you are building a web application, you need to define a view resolver. If you are building a database related application, you need to define a data source. So there is a lot of configuration that you need to put in place before you'd be able to use your application. In addition, you also need to worry about non-functional requirements. Your application needs to have logging. You need to have good error handling for your application. You need to be able to monitor your application in production. You need to be able to look at metrics for your application in production. So in the world before Spring Boot, you needed to manually implement these non-functional features, logging, error handling, and monitoring. So in the world before Spring Boot, setting up projects was not easy. You needed to manage dependencies. You needed to provide a lot of configuration in your web.xml, in your Spring context, and you needed to write a lot of code to implement your non-functional requirements. And you need to repeat this for every new project. Every few months, let's say you're building a new project, you need to keep repeating this. This takes a lot of time, typically a few days to set up. And if you're maintaining for a long time, then you need to spend countless hours to maintain the code you write. The goal of this step is to give you a high-level overview of the world before Spring Boot. You needed to manage your dependencies, you needed a lot of configuration, and you needed to manually implement the non-functional requirements. Now, you might be wondering, how does Spring Boot make it easy? That's what we will be exploring in the next few steps. To understand the power of Spring Boot, what we'll do is we'll create a Spring Boot project in the next step. And after that, we will start building a simple REST API using Spring Boot. Are you ready to understand the power of Spring Boot? I'll see you in the next step. In this step, let's get started with creating a Spring Boot project. Creating a Spring Boot project is very easy. All that you need to do is go to the website start.spring.io. This is called Spring Initializer. Over here, you can make a few simple choices and get started with your Spring Boot project. I will choose Maven as my build tool. I'll choose Java as the language. We are recording this course with Spring Boot 3. Right now for Spring Boot 3, there are snapshot versions and milestone versions. Therefore, I would choose milestone version. If by the time you're watching this course, there is a released version for Spring Boot, if there is a version without snapshot or M1 or M2 or M3, something like 2.7.1 in here. So if you see 3.1.0 or 3.2.0 or 3.3.0, go ahead and use that. For now, the latest milestone release of Spring Boot 3 is 3.0.0 M3, and I'm going to make use of that. One recommendation, do not use snapshot versions. Snapshot versions are versions under development. These are being actively developed by the Spring and Spring Boot teams, and therefore you should avoid them as much as possible. The next thing we would want to configure is the project metadata. Group ID and the artifact ID are very, very similar to your class name and package name. When I create a class, I give it a name and I put it into a package. Similarly, when I create a project, I would need to give it an artifact ID and also place it into a group. The group I'm going to make use of in here is com.in28minutes.springboot. And the artifact ID I would give is learn-spring-boot. I will choose the defaults for the rest of the values in here. Spring Boot 3 needs at least Java 17. So you can use Java 17 or a higher version of Java. At in 28 minutes, we always ensure that our courses are compatible with the latest version of Spring Boot and Java. So do not hesitate in making use of the latest versions. The last thing we would need to configure in here are the dependencies. We would want to create a Spring Boot project. What kind of project do we want to build? We would want to build a REST API. And to be able to build REST API, we would need a dependency. What's the dependency? It's called Spring Web. This is actually Spring Boot Starter Web. This is used to build web applications and REST API with Spring MVC. This uses Apache Tomcat as embedded container. So let's choose Spring Web. And now we are ready to create our Spring Boot project. All that you need to do now is to click the generate button in here. This would generate a zip file and download it to your downloads folder. As you can see, creating a new Spring Boot project is very, very easy. What I've done is I've extracted the zip file in my downloads folder to a folder on my hard disk. You can choose a convenient folder on your hard disk, something like C:/. Once you have all the code in a specific folder, we are now ready to import it into our IDE. I have already launched up Eclipse and I have chosen a default workspace. And we would want to now import the project into Eclipse. You can either do a file import or you can click import projects in here. So in the file menu, you can choose import or you can click import projects in here. And over here, I would type in Maven. If you type in Maven, you would see something called existing Maven projects come in. So file import existing Maven projects, click next. And I would recommend you to browse to the directory where you have extracted your zip file to. I've extracted my zip file to this specific folder in here. So I'll say open. You'd see a pom.xml come up and you'd see its group ID and artifact ID. Com in 28 minutes Spring Boot, learn Spring Boot. This will match the group ID and the artifact ID that we configured in here. Let's now go ahead and say finish. If this is the first time you are making use of this specific version of Spring Boot, the import would take a long time, typically about 10 to 15 minutes. If you have any problems, one thing I would recommend you to do is to use the latest version of Eclipse IDE for Java enterprise developers. Once the project is imported in, you should see a structure like this in your Project Explorer. Source main Java is where your Java code or the source code would go in. This is your application configuration, source main resources, and source test Java is where you write your unit tests. You would see that there are a lot of Maven dependencies which are coming in. And you will see a file called pom.xml where you would see a couple of dependencies which are defined. Spring Boot Starter Web and Spring Boot Starter Test. All the dependencies which you see in here, the Maven dependencies which are in here, are coming in because of these two starter projects. We will discuss a lot about starter projects as we go further in the specific section. For now, let's focus on getting this application up and running. The way you can do that is by going to source main Java, opening up com in28minutes Spring Boot learn Spring Boot package, and you should see a file called learn Spring Boot application.java. This file has a main method, and this main method is what we would want to launch up. So I'll say right click, run as Java application, and this would launch our Java application up. If you go to the end of the logs, you would see that Tomcat is started on port 8080. And you will see that this application started up very, very quickly, less than a second. In this step, we created a Spring Boot project. We saw that it was very, very easy to create a Spring Boot project using Spring Initializer. All that we needed to do was to make a few choices and click the generate button. A project was created. We imported that project into Eclipse and we were able to also launch it up. The application was launched in Tomcat server on a specific port. You also saw that a lot of logs are generated. How is this magic happening? How does Spring Boot work? To understand that, we'll build a simple REST API using Spring Boot. You will see that this will not take more than a few minutes. I'll see you in the next step. In the last step, we saw that it was very, very easy to create Spring Boot projects. In this step, to understand the power of Spring Boot, we'll see how you can build a simple REST API. Let's go over to our IDE. What I would want to do in here is to create a simple REST API. So I'll create a new class. You can say file new or right click new in here. Choose class, and I would want to create something called course controller. And I'll say finish. What do we want to do inside the course controller? What we want to do is to create an API like this. So I'll pick up the URL in here and the data we would want to return back in here. So what we want to do is to create a simple REST API with the URL /courses. And when somebody hits that URL, what we want to do is to return this data back. So we would want to return course details with ID, name, and author. This is what we would want to return back from our course controller. What do you want to do in the course controller? We would want to build a REST API. That's why I would use the annotation REST controller. That's why I would use the annotation REST controller. So if you do an organize imports, you should see org Spring Framework web bind annotation REST controller imported in. Now that we have the @REST controller annotation on this, you can create methods in here and expose the link that we would want to create. So this is what we want to do in here. So we would want to retrieve a set of courses and return them back. So a set of courses. So let's create public list of course. So we'll be returning a list of courses, and I'll call this retrieve all courses. And this method will not have any parameters, and let's create the body of the method. What we want to do in here is to return a list of courses. So return arrays.asList. Arrays.asList is a method in arrays class, java.util.arrays. So I'll remove the null and I'll put a semicolon at the end. Inside this, I'd want to create our new courses. So I'll say new course of, let's say ID is 1. The name is Learn AWS, and let's say the author is in 28 minutes. And we would want to create another bean, learn, let's say DevOps, and the course ID, let's say this is 2, and let's say the author is in 28 minutes. Now, you should see a set of compilation errors in here because we don't have the course class. We have not imported the list in here. So the first thing I'll do is organize imports. So if you do a Control-Shift-O or Command-Shift-O, you should see an import for Java util list. So that's good. One compilation error fix. The next one is that the course class does not exist. How can we fix this? The way we can fix this is by pressing Control-1 or Command-1 in here. So what we want to do in here is to create a class called course. So let's go ahead and say create class course. I'll take the defaults and say finish. And over here, we would want to define all the attributes that we would want to have. So let's say I would want to have a ID, private long ID, private string name, and private string author. These are the fields I would want to store for the course. As usual, let's go ahead and create a few methods in here. We would want to create a constructor. We would want to create getters for this, getter methods, and we'll also want to create a toString method. The toString, so let's go ahead and generate them. The way you can do that is by saying right click source and generate toString. So let's start with toString. So I'll generate the toString method in here. So the toString method is now here. So let's move this above. So we generated the toString now. The next thing that we want to generate is the getters. So right click source, generate getters and setters. And I only want getters. So I'll say select getters and say generate. So we have the getters generated, get ID, get name, get author. The toString method is generated and it's at the top. So I'll move that to the bottom. So typically toString method should be present at the end. Whenever we print an object of the course class, the toString method is called and all the details of the course would be printed. And these getter methods would be helping us to retrieve the values of a course whenever we need them. The last thing we would need is the constructor. So let's generate the constructor also. Right click source, generate constructor using fields. And I would want to choose all the things in here, ID, name, author. And I would want to insert it after the author field. So let's go ahead and generate. So we now have the constructor also in here. So you have a constructor accepting ID, name, and author. If you see this, this is exactly matching what we have in here. One, learn AWS in 28 minutes. ID, name, and the author. And now when you save all the files, you'd see that the code would compile. So that's awesome. We now have compiling code. What we want to do is to map a URL to this specific method. What's the URL I would want to map? /courses. When somebody hits /courses, I would want to return this list of courses back. How can I do that? At request mapping. And over here, I can map the URL /courses. If you do an organize imports, you'd see that org, Spring Framework, web, bind, annotation, request mapping is imported in. So now I can remove all the comments in here, Control D or Command D, and save this out here. So what we have in here is a simple course controller from where we are exposing /courses. So we would want to be able to use this URL. And when we go to this URL, we should see a list of courses come back. Let's go ahead and stop and start the application up. You can go in here and start Learn Spring Boot application, or the other approach would be to go in here, Learn Spring Boot application, and right click Run as Java application. Either of these approaches should be fine. One thing you need to remember is you need to stop the application before you can start it up. So I've stopped and started the application, and let's go to the browser and type in the URL localhost 8080/courses. Awesome. You can see that a JSON response is coming back. If you see an unformatted response, I would recommend you to install this extension. So JSON formatter, Chrome extension. This would take you to an extension called JSON formatter. I've installed this specific extension, and that's the reason why you would see that this JSON is formatted. If you look at the raw, it would be something like this. However, if I'm using the JSON formatter plugin and formatting it, this is how it would look. So we have a couple of courses which are returned back. Learn AWS in 28 minutes. Learn DevOps with in 28 minutes. As you can see in here, creating REST API with Spring Boot is very, very easy. We did not need to focus on anything else. All that we needed to focus on was the business logic. What do we want to do? We did not need to configure any Spring Beans or any XML at all. How is Spring Boot making this possible? That's what we'll be exploring starting the next step. In the last couple of steps, we saw that it was very, very easy to create a Spring Boot project and expose a simple REST API. You saw that it was very, very easy to do this with Spring Boot. However, there is a lot that is happening in the background with Spring Boot. When you want to make the best use of Spring Boot, you need to understand what's happening in the background of Spring Boot. And that's what we will be doing starting the next step. Having built a simple REST API with Spring Boot, in this step, let's understand what's the most important goal of Spring Boot. The most important goal of Spring Boot is to help you build production-ready applications quickly. There are two very, very important words in here. Quickly. You'd want to be able to build applications faster. And you also want applications to be production-ready. There are a lot of features that you need in an application before you would be able to put it to production. So the goal of Spring Boot is to enable both of this. Let's look at some of the features that enable you to quickly build applications with Spring Boot. We already looked at Spring Initializer. It helps you to easily create Spring Boot projects. That's the website start.spring.io. The other features which help you to build applications quickly are Spring Boot starter projects, Spring Boot auto configuration, and Spring Boot dev tools. Spring Boot starter projects help you to quickly define dependencies for your projects. Spring Boot auto configuration would automatically provide configuration based on the dependencies which are in the class path. And Spring Boot DevTools will help you to make application changes without having to manually restart the server. We'll be exploring these three features in the next 3 steps. Is it sufficient if you are able to build applications quickly? Nope. You also want them to be production ready. You need all the features that are important when you take your application live to production. You need things like logging. You need to be able to provide different configuration for different environments. Applications typically have different environments, dev environment, QA environment, staging environment, production environment. And you would want to have different configuration for these environments. And you also want to be able to monitor your application. You'd want to be able to see if there is sufficient memories. You'd want to be able to look at the metrics for your application. Spring Boot provides you with a number of features which help you to get to a production-ready state very, very fast. Spring Boot provides default logging. Spring Boot provides features like profiles, configuration properties, and Spring Boot Actuator as well. In this step, we talked about the important goal of Spring Boot, and we mapped some of the important Spring Boot features to this specific goal. In the subsequent steps, we will start exploring each of these features individually. We already talked about Spring Initializer, so let's get started with Spring Boot starter projects in the next step. Ooh, I hope you loved the last few steps. Do you know? More than 1 million learners are pursuing in 28 minutes courses. Go to our website www.in28minutes.com and click on roadmaps to check out all our amazing roadmaps. We have wonderful roadmaps to help you get started with cloud, DevOps, programming, and variety of frameworks. Don't stop learning. Don't stop having fun. Now, let's get back to the next step. Welcome back. One of the most important features of Spring Boot is Spring Boot starter projects. Typically, whenever I need to build an application, I need a lot of frameworks. For example, if I would want to build a REST API, I need Spring Framework, Spring MVC Framework, I need Tomcat to run the application in, I would need to do JSON conversion. If you look at this specific REST API, we are returning a list of courses back. If you look at the response, it's a JSON response. This is what is called JSON conversion. From your Java list of courses to a JSON list. So whenever we're building a REST API, we need all these things. If let's say I would want to write a unit test, I would need Spring Test Framework, I would need JUnit Framework, I would need Mockito Framework. So whenever we want to build any application feature, we need a lot of frameworks. The question is, how can I group them and make it easy to build applications? That's what starter projects provide. They provide convenient dependency descriptors for different features. If I open up my pom.xml, it's directly in Learn Spring Boot. So Learn Spring Boot, pom.xml, this is where we define all our Maven dependencies. And over here, you would see that we are making use of two different starter projects. What are the starter projects we are making use of? Spring Boot Starter Web and Spring Boot Starter Test. Spring Boot Starter Web enables you to build REST API and web applications. Spring Boot Starter Test helps you to write unit tests. You can go ahead and do a control click or a command click in here. This would open up Spring Boot Starter Web. Spring Boot Starter Web, starter for building web, including RESTful applications using Spring MVC. If you scroll down in here, you would see that it defines a number of dependencies in here. What are the dependencies which are defined in here? The first one will help you to launch a Spring context. We would want to do bean to JSON and JSON to bean conversion. That's Spring Boot Starter JSON. It helps you with JSON conversion. We would want to be able to run the application in Tomcat. That's where we would make use of Spring Boot Starter Tomcat. And we would want to be able to use Spring MVC framework to build our REST API. So these are the dependencies for that. So as you can see in here, Spring Boot Starter defines all the dependencies that you would need to build a specific kind of application. For example, to build a web application or REST API, these are the things that you would typically need, and these are predefined for you. So Spring Boot starters are nothing but convenient dependency descriptors. If I would want to build a web application, I need A, B, C, D, E, F, G, and all of them are predefined for me when I'm making use of a starter. Spring Boot provides you with a variety of starter projects. Depending on the feature you need for your specific project, you can make use of different starter projects. If you are building a web application and REST API, you can make use of Spring Boot Starter Web. We saw that it brings in dependencies Spring Web MVC and Spring Web. These are Spring MVC. It brings in Tomcat. It brings in JSON conversion and things like that. Similar to this, there are a number of other starters. If you want to be able to write unit tests easily, you can make use of Spring Boot Starter Test. If you want to be able to talk to a database, let's say you want to use a database like Oracle or MySQL, and you'd want to be able to write code to talk to the database using JPA. In that kind of scenario, you can make use of Spring Boot Starter Data JPA. If you want to talk to a database using JDBC, in that kind of scenario, you can make use of Spring Boot Starter JDBC. If you want to secure your web application, or if you want to secure your REST API, you can make use of Spring Boot Starter Security. In this step, we talked about Spring Boot starter projects. There are two key takeaways as far as I'm concerned. Number one, Spring Boot starter projects are convenient dependency descriptors. To build a specific kind of application, you might need set of dependencies. For example, to build a web application, you need a set of dependencies. All of these are predefined in starter projects. Number two is the fact that Spring Boot provides you with a variety of starter projects. Depending on your use case, you can choose the right starter project. Now, is it sufficient if I have the right dependencies in the class path? Nope. You need to also configure them. That's what we'll be looking at in the next step. In the last step, we talked about Spring Boot starter projects. In this step, let's look at Spring Boot auto configuration. Typically, whenever you want to build a web application with Spring Boot, you need a lot of configuration. You need to configure component scan, dispatcher servlet. If you want to talk to a database, you need to configure a data source. You need to configure conversion from bean to JSON, JSON to bean. So there are a lot of things that you need to configure to build a typical Spring application. How can I simplify this? That's the concept of auto configuration. Automated configuration for your application. How is this generated? The automatic configuration is generated based on which frameworks are in the class path. In the pom.xml, we can add in a lot of starter projects, and these bring in a lot of frameworks. So depending on the frameworks which are present in the class path, we can auto-configure a lot of things. The other factor is what is the existing configuration. Spring Boot provides default auto-configuration. However, you can also override that by providing your own configuration. So a combination of these two things is what is used to determine auto-configuration. What frameworks or what classes are in the class path, and what is the existing configuration that you have provided. Now, where is all the auto-configuration logic defined? All the auto-configuration logic is defined in a specific jar, which you would be able to see in your Maven dependencies. It's called Spring Boot auto-configure.jar. If you go in here, you would see a number of auto-configuration classes which are present in here. If you scroll down, you should see a package or Spring Framework Boot auto-configure web. All the auto-configuration related to developing web applications and REST API is configured in this package and its sub-packages. Now, if you want to understand auto-configuration further, what you can do is to open up application.properties. So where is application.properties present? It's in the source main resources. If you go to source main resources, you have application.properties. You can go to application.properties and configure logging level. So I'll say logging.level.org.springframework is equal to debug. What we are saying is, for this particular package org.springframework, we would want to log at debug level. So we are changing the logging level for org.springframework. I'll save this, and for us to pick the change, I'll need to stop the server and start the server up again. So learn Spring Boot application, I'm launching it up again. And now you would see that there is a lot more log. The default logging level is info, and info prints very, very less information. However, when we changed it to debug, you would see that there is a lot of information which is printed in. If you look at the logs in depth, you would see that there is something called conditions evaluation report. In there are positive matches and there are negative matches. Negative matches are things which did not get auto-configured. Positive matches are the things which were auto-configured for you. A dispatcher servlet was auto-configured for you. You can see that an error page is auto-configured for you. You can see that Tomcat was auto-configured for you. So all this auto-configuration is based on the code which we see in this specific jar, Spring Boot auto-configure.jar. Let's pick up one of the classes from there. Let's look at dispatcher servlet auto-configuration. Command Shift T or Control Shift T, you can open the class up. Dispatcher servlet auto-configuration. If I click this icon which is present in here, you can see the dispatcher servlet auto-configuration.class in here. Where is it present? Yep, you are right. Spring Boot auto-configure.jar. This is where it is present. And over here, you can see configuration of when this specific auto-configuration is enabled. So this is enabled for a web application or a REST API. And this is enabled when there is something called dispatcher servlet in the class path. Because we included Spring Web Starter, dispatcher servlet is already on the class path, and therefore the dispatcher servlet is auto-configured for us. If you scroll a little down, there is something called error MVC auto-configuration. Let's launch it up. Command Shift T or Control Shift T, error MVC auto-configuration. Let's open it up. And this is the thing which is configuring a default error page. Now, what's a default error page? Earlier, when we typed in the URL localhost 8080 courses, we get the proper response back. However, let's say I type in a URL which we have not mapped anything to. For example, I'll say courses/10 and press enter. You'd see that you get a white label error page. It's saying not found. This page is not found. The status is 404. So the application is able to understand the fact that the URL is not mapped, and it's able to provide a good error message back to the user. How is this happening? The reason it is happening is because of the error MVC auto configuration class. Spring Boot automatically configures an error page for you. Now, if I actually take this white label error thing, now if I go in here, copy this and search for it in here, you would see that white label error page is coming in from here. This is auto configured for us by Spring Boot auto configuration. So what we are looking at is the fact that Spring Boot auto configures a lot of things for you based on the frameworks which are present in the class path. A good example is Spring Boot Starter Web. When you're using Spring Boot Starter Web, all these things are automatically auto-configured for you. A dispatcher servlet, an embedded servlet container. We want to use Tomcat to run our application. So by default, Tomcat is auto-configured. Default error pages are auto-configured for you. And also, we saw that JSON conversion is auto-configured for you. The JSON conversion is done by a framework called Jackson. Spring Boot auto configuration, when you have Spring Boot Starter Web on the class path, would automatically provide a message converter from bean to JSON. And that's the reason why when we were returning a bean, an array list from our method, it was automatically converted out to JSON. This magic is happening because of the Jackson HTTP message converters configuration. In this step, we looked at Spring Boot auto configuration. In the last step, we understood the fact that Spring Boot starter projects bring in a lot of dependencies. And Spring Boot auto configuration would look at the dependencies, look at the jars, classes, and it would provide automatic configuration for your application. All the logic for Spring Boot auto configuration is present in a jar file called springboot autoconfigure.jar. I'm sure you're having a wonderful time, and I'll see you in the next step. In the last few steps, we looked at 3 Spring Boot features which help you to build applications fast. 1 was Spring Initializer, 2 was Spring Boot Starter Projects, 3 is Auto Configuration. And now we are going to talk about the 4th one, which is Spring Boot DevTools. Spring Boot DevTools helps to increase developer productivity. Whenever you build applications, you want to build them very, very quickly. Developer productivity is very, very important. The question Spring Boot DevTools asks is, why do we need to restart the server manually for every code change? How about automatically restarting the server and picking up the code change? Let's quickly see Spring Boot DevTools in action. The way you can use Spring Boot. To make use of DevTools, we need to add it to our pom.xml. So open up pom.xml, and what we need to add in is Spring Boot DevTools. So I'll copy Spring Boot Starter Web, paste it in here, and I'll change starter-web. I need to remove that and add in DevTools and save this. Wait for a little while until it's downloaded and the project is configured. And once the project is configured, you should not see any errors on the project. You can stop the server and you can start it up. Now I'll go to the course controller class. We have the list of courses defined in here. So if I refresh localhost 8080 courses, I have these courses in here. Now what I would want to do is to make a small change in here. Let's say I'm adding a new course. So let's say I would want to add Learn Azure. And let's say the ID of this is 3. Now, as soon as you save the change, you'd see that in the console, a restart is happening. A restart is automatically triggered. And if you refresh it in here, I get an error. It says syntax error on token comma. Why? The reason why there is an error is because I added in an extra comma in here. Let's remove the comma and save this. Now, immediately you'd see that there is some log coming in. So the application is being restarted. And if you refresh the page, you can see that I'm getting the changed functionality based on the new class. So I'm getting Learn Azure as well. So now testing our code changes becomes really, really easy. Let's say I would want to add another feature. Let's say I'm adding a method or a class and I'm making a change in there. All that you need to do is to go in, make the change without an error, obviously, and save it. And you'd see the magic in action. You can see that the change is automatically picked up and you can easily test it. In this step, we talked about Spring Boot DevTools. Spring Boot DevTools aims at improving developer productivity. Why do you need to restart the server manually for each change? Once you add the dependency for Spring Boot DevTools, you would see that if you make a Java file change or if you make a property file change, Spring Boot DevTools would automatically trigger a restart of the application. So you don't need to manually restart your server. One very, very important thing to remember is that if you are making any changes to pom.xml, this is where we define all our dependencies. Right now, what are the things which we have defined in the pom.xml? Let me open that up, pom.xml. Right now we have Spring Boot Starter Web, DevTools, and Starter Test. If you're making any changes in the pom.xml, you need to stop and start the application manually. Spring Boot DevTools cannot handle changes in pom.xml. However, for most other files, for example, property files, view files, Java files, for all those kind of changes, you don't need to manually restart the server anymore. Woohoo! I'm sure you love the last few steps. Do you know? I love traveling and I'm a regular on Instagram. Go ahead, check out our Instagram to know about all the fun things I do. You can find a link to my Instagram profile on my website, rangakaranam.com. Don't stop learning, don't stop having fun. Now, let's get back to the next step. In the last few steps, we looked at features that Spring Boot provides to help you quickly develop applications. Starting this step, let's look at some of the important features that Spring Boot provides to help you create a production-ready application easily. The first feature that we'll be looking at is managing application configuration using profiles. Whenever we talk about applications, they have different environments. You have a development environment, a QA environment, a stage environment, a production environment. And different environments need different configuration for the same application. For the same code, you'd want to have different configuration in different environments. You might be talking to a different database, or you might be calling a different web service. Dev environment would be talking to dev database. Test environment would be talking to test database. Production environment would be talking to production database. That's the concept of profiles. Profiles enable you to provide environment-specific configuration. Let's say I want to configure different things for my environments. I might have a dev environment. I might have a dev environment, a QA environment, a stage environment, and a production environment. Whenever you have configuration that you would need to manage for different environments, you can go and create a separate profile for each one of these. So you can create a profile for dev, a profile for QA, a profile for stage, and a profile for prod. And you can create separate configuration for each of these environments. How do we do that? Let's keep things simple. I'll just say I have two environments, dev environment and the production environment. Right now, we have application.properties. In the application.properties file, which is in source main resources, application.properties, we have logging.level.org.spring-framework is equal to debug. So this is printing information at debug level. However, let's say in my dev environment, what I would want to do is I don't want to print it at debug level, but I would want to print it at trace level. So trace is even lower, so it will print even more log. And let's say in the prod environment, in the prod profile, I'd want to configure it at info level. I don't want to log everything. I only want to log only the important information. How can I do that? That's what profiles enable you to do. So what I can do in here is go to application.properties, copy paste it. Let's save all the changes. And I'll call this application-dev. It's very, very important to note. It's application-dev.properties. And in dev, which logging level do we want to use? We want to use trace. So I'll put trace logging level in here. And I'll also copy this file and paste it again. And I'll create a file called application prod.properties. In prod, what is the logging level we would want? I would say info. So we have application-dev with trace, application-prod with info. And we have application.properties where we have debug. Right now, by default, this application is not making use of any profiles at all. When you're not making use of any profiles, the application makes use of the default properties which are configured in application.properties. Therefore, you would see debug log and all levels which are below debug log, which includes info. Now let's say I go in here and I would want to configure a profile of production. The way I can do that is by saying spring.profiles.active is equal to prod. So if I configure a specific profile, the values from the default configuration, which is present in application.properties, and the values from application-prod are merged together. Whatever is configured in application-prod, that specific profile has higher priority. So over here, we are saying logging.level.org.spring-framework is equal to info. And the same logging level in here is debug. So the value in the profile application-prod.properties has higher priority. So you would see that that gets higher priority and only info log would be printed now. So if you look at the last few things which are printed in here, you would see that only info is printed in here. Now let's say this is the development environment. If I'm deploying this to development environment, I can configure the active profile to dev. I will remove the log which is present in here and save it. You would see that now trace information is also printed in here. So it's printing trace, debug, and info. Typically, whenever you look at logging frameworks, there are multiple logging levels which are supported. Trace, debug, info, warning, error, and off. Off would actually turn off entire logging. If you use error, only errors and exceptions would be printed. Warning is one level above, which prints a little bit more information. Info would print all the things which are logged at info level. Debug would print a lot more information, and trace would print everything there is to log. So these are the different logging levels which are typically used by most logging frameworks. And one of the things that you need to know is that if you enable trace, if the logging level is set to trace, like it is set in here, in that kind of scenario, everything is printed. So if you set it to trace, debug, info, warning, error, and off. If you set it to trace, then all the levels below it, debug, info, warning, and error would be printed. If you set the logging level to debug, then debug, info, warning, and error are printed. If you set it to info, warning, and error are printed. So warning prints warning and error prints only the error information. So having a high level overview of this is very, very important as we look more at logging. In this step, we talked about the fact that applications have different environments and different environments might need different configuration. For example, the logging level in different environments might need to be different. And that's where you can make use of profiles. You can create multiple profiles for different environments with the names application-dev, application-prod, application-QA, and so on and so forth. And you can use active profiles to set the profiles which you would want to be active. The example which we looked at in this specific step is a trivial one. We were playing with different log levels. Let's look at a much more complex example in the next step. In the last step, we talked about profiles. Profiles enable you to have different configuration for different environments. In this step, let's look at how you can set up complex configuration for your application. Let's say I have a currency service that I am talking to, and I would want to configure a lot of values for it. Currency service.url, let's say currency service.username, and I would want to be able to configure a currency service.key. In addition, let's say there is a lot of other configuration I would want for different other services as well. How does Spring Boot help us manage this application configuration? How can I define a property value in here and make use of it in a Spring Boot application? If you want to create a lot of application configuration for your application, then the recommended approach in Spring Boot is to use something called configuration properties. Let's go ahead and create a class. I'll call this currency service configuration. Now, what are the things I would want to define in here? Let's go in here. These are the values which I would want to define. So let's see how to define these in here. the first thing you need to do is to add an annotation called configuration properties. So let's do a control1 or command1 and import it in. And what is the prefix that we would want to use? It's currency service. So for all the values, I would want to use the same prefix. So if you do a control space or command space, you can see a prefix in here. And you can configure currency service as the prefix. And what are the properties that you would want to have? Private string URL, private string, let's get this right, string username, and private string key. So these are the three attributes we'd want to store for currency conversion configuration. Let's go ahead and generate constructors and setters. Right click source, generate getters and setters, and generate getters and generate getters and setters for all these. So let's do a generate, and let's format the code, Control Shift F or Command Shift F. And now the prefix is defined, currency service. All our properties are defined. And in addition, we need to add at component. We would want Spring to manage this. That's the reason why we are adding in at component. So let's organize imports. You can see that org Spring Framework stereotype component is imported in. Now your application is ready. Your application understands the configuration properties and these. Where do you configure this? You can configure these in your application.properties. For now, I'll say http://default.in28minutes.com, and I'll call this default username and default key. Now your application.properties has these properties configured, and we have currency service configuration, which is mapped to the properties which is present in here. Now we would want to see if our code is working, if the mapping from application properties to the currency conversion to the currency service configuration is working. And one of the approaches to quickly look at it is to create a simple controller. So I'll copy course controller, Control C, Control V, and I'll call this currency configuration controller. I'll open up the currency configuration controller, and over here we'd want to actually return currency configuration back, and this would not be returning list of this would be returning configuration. This will be returning currency service configuration, and I would want to be able to get an instance of this currency service configuration which is created by Spring. So we are saying at component in here, so Spring would create an instance of it. So what I can do in here is to auto wire it in. So I can say at auto wired and private currency service configuration. So we are auto wiring the bean which is created in here. Spring would create this bean, we are taking it up, and we are auto configuring it in here, and all that we need to do now is to return it as a response for our simple service that we are creating in here. This will help us to look at the values which are configured right now. So let's save this, and if you go over and type in, instead of courses, currency configuration, we need to have a single slash. So localhost 8080 currency configuration, press enter. You can see that these values which we configured in application.properties are coming up. Default.in28minutes.com, default username, default key. Now let's go in here. Let's change the properties to just say default 1 and save it. Give the application a little bit of time to restart and pick it up and refresh. You can see that the values are coming in from application.properties. Right now you can see that the active profile is dev, and we are not overriding these properties in the dev profile. So we are making use of the default properties which are configured in here. However, let's say I would want to make use of different properties in the dev profile. How can I do that? I can go to application dev.properties and I can configure it in here. I can go in here and say this is dev.in28minutes.com, and this is the dev username, and this is the dev key. So what we are doing is we are configuring different values in the dev environment. Let's save this. And if you go and refresh, you can see that the values are now coming in from the dev environment. So if you have complex application configuration like this to create, in those kind of situations, you can make use of @configuration properties. @configuration properties is very, very easy to use. All that you need to do is to create a Spring component and annotate it with @configuration properties. You can have as many properties as you would want in here. I've seen applications which have hundreds of properties which are defined in here, and this would act as the centralized class for all the application related configuration. So a combination of configuration properties and profiles in Spring Boot is very, very powerful. It enables you to externalize all the configuration that is needed for your application. In this step, we talked about configuration properties and profiles. I'm sure you're having a wonderful time, and I'll see you in the next step. Welcome back. In this step, we'll be talking about embedded servers. How can you simplify deployment with Spring Boot embedded servers? Whenever we want to deploy something to production, we would want our deployment process to be really, really simple. Why? Because we have multiple environments. You have a dev environment, a QA environment, a staging environment, a production environment. And typically, if you are following an agile approach, then you might be doing multiple deployments per day. So making your deployment processes as simple as possible is very, very important. Let's quickly look at the old approach of deploying applications. This is called the var approach. The first thing is to install Java. Once you install Java, then you need to install a web server or an application server. You would have heard about Tomcat, WebLogic, WebSphere. These are all famous web or application servers. So first you would install Java, then you would install this specific web server, and after that, you would deploy the application var file. So this is the old var approach, which is a little complex to set up because you have 3 different steps. Install Java, install your web server, and then you can go ahead and deploy the var. The concept of embedded server is a simpler alternative. When you are making use of embedded server, the server or something like Tomcat is already part of your jar file. And therefore, all that you need to do is to install Java and you are ready to run your jar file. Let's see this in action right now. What I'll do is go in here and I would say right click, run as Maven build, and I'll type in clean install. So I'm putting in the goals clean install. This would run a command called mvn clean install. Let's see what would happen when mvn clean install is executed on our project. For me, the execution took about 2 seconds because I've already run this once before. If you're running this for the first time, you would see that this would take almost a couple of minutes to complete. Wait for that to complete. And what I would recommend you to do is to go and copy this line in here, building jar. So a jar is being built for us. Let's see what jar is being printed. So let's go in here and put that in here. Now over here, I'll remove building jar in here and go to the end. You can see that there is a specific folder where a jar file is being created, and this is the name of the jar file. So what I'll do is I'll open up terminal or command prompt and cd into this specific folder. So if I say cd into this specific folder and press enter and go ahead in here and type in ls or dir, ls on Mac or Linux, dir on Windows, we are looking at all the files in this specific folder. You can see that there is a file called learn springboot 0.0.1 snapshot.jar, which is created in here. So what I do is I would want to run this jar file. So I'll say java-jar and paste that jar file name. So java-jar learn springboot 0.0.1 snapshot.jar. Before running it, make sure that you have the right version of Java installed. We are making use of Spring Boot 3, so you would need at least Java 17. I have Java 18 in here, so that's good enough. You can also use any of the latest versions of Java if they are available by the time you're watching this course, Java 20 or 21 or 22, whatever. Now let's try and run the jar file. So java-jar and paste it in. Learn Spring Boot 0.1.1 snapshot.jar. Awesome. The application is now being launched up, and you can see that I'm getting an error. It says port 8080 is already in use. Why? Because we had an application launched up in here. So let's stop the application which is running in here. So let's go in and stop this, remove this out, and now launch it up in here again. So you can see that the application is now ready. It's very, very easy to launch the application using a jar file. And I would be able to go in and execute the URLs of the application again. And you should see that everything works fine. So if I go to courses, you should see a list of courses coming back. So right now, we saw that to run our application, which is built using Spring Boot, we just needed Java installed. Once we have Java installed, we build the jar file and we are able to run the jar file. We don't need the web server installed because the web server is part of our jar file. If you open up Spring Boot Starter Web, so if you go over to our pom.xml and open up Spring Boot Starter Web. So if you Control click or Command click, and over here, if you scroll down, you would see that Spring Boot Starter Web automatically brings in Spring Boot Starter Tomcat. And this Tomcat is already part of our jar. And therefore, to run our application, we just need Java. You install Java and you can run the jar file. And this would simplify the entire deployment process. Now let's go back. I'll do a Control-C or Command-C to terminate this. So I'm terminating the application which we have launched in here. Embedded servers help in simplifying your deployment processes. And that's why Josh Long, Spring and Spring Boot developer advocate, he says, make jar, not var. Spring Boot supports a number of embedded servers. The default is Spring Boot Starter Tomcat. So that's the one which is used by default. However, there are other things like Jetty and Undertow which are also supported. In this step, we talked about embedded servers. We saw that deploying an application is very, very easy when your application is making use of an embedded server. All that you need is Java installed. Once you have Java installed, you can run the jar. I'm sure you're having a wonderful time, and I'll see you in the next step. I'm sure you are loving the video until now. Do you know, I write an amazing newsletter every month about cloud, DevOps, and other emerging technologies. Do you want my opinion on what you should learn and how you can learn fast? Do not forget to check out my newsletter. You can go to the website rangakaranam.com and you can find a link to the newsletter in there. Keep learning every day. Now, let's get back to the next step. In this step, we'll look at another important feature of a production-ready application, monitoring. You'd want to be able to look at what's happening in the background with your application. The Spring Boot feature which enables you to do that is Spring Boot Actuator. It helps you to monitor and manage your application in production. Spring Boot Actuator provides you with a number of endpoints. You'd be able to look at all the Spring Beans which are part of your application using this Beans endpoint. You have health endpoint where you can look at the application health information. Is your application up and running? That's health. You can also get a number of metrics related to your application going to the metrics endpoint. And you also can get details around all the request mappings that are configured in your application when you go to the mappings endpoint. There are a lot of other endpoints which are exposed by Spring Boot Actuator. What I'm showing in here is a selection of them. Now, how do you make use of Spring Boot Actuator? As usual, it's very, very easy. So let's go over to our pom.xml and I'll copy the starter web and I'll say Spring Boot Starter Actuator and save this out. I don't have any application running right now, so that's cool. So I can go ahead and launch the application up from here. So learn Spring Boot application. Let's launch that app. The application is now up and running. And let's go over to the browser and type in the URL localhost 8080 actuator. You'd see this JSON response come back. It has a link to the self, to the current URL, and it has a link to the health URL. So if you click the health URL, localhost 8080 actuator health, you'd see the status of the application. The status of the application is currently up and running. By default, whenever you launch up Actuator, it will only expose the health endpoint. If you want more features from Actuator, you need to enable them in application.properties. You can go to the application.properties and type in management. We would want to configure additional endpoints. So web.exposure.include is equal to star. So this would expose all the endpoints which are provided by Actuator. So you can see that the application has started up, and I would go in and refresh the Actuator URL. So localhost 8080 Actuator, I've refreshed it. And now you should see a number of endpoints which are shown in here. You don't really need to understand every endpoint which is present in here. Let's quickly take a look at some of the important ones. So if you look at Springboot Actuator beans, this should show all the Spring beans which are loaded. Earlier, we created course resource. Earlier, we created a course controller. You'd see that there is a bean for course controller. There would be a bean for dispatcher servlet. There would be a bean for error MVC configuration. So for all the things which are auto-configured, you should see a bean which is present in here. So if you want to find out if a specific thing is auto-configured or not, this is another way you can do that. You can go to Actuator beans and see if a specific Spring bean is configured for you. So that's localhost 8080 Actuator beans. Let's close that. In addition, we already looked at the health. Health is exposed by default. That's always present. The next endpoint we'll look at is config props. Localhost 8080 Actuator config props. If you open that app, you should see all the things that you can configure from application.properties for our application. You would also see the specific thing that we have created. We have created currency service configuration. So you can configure values for currency service. The way you can configure it by currency service.url, currency service.key, currency service.username. You can also see the current values which are picked up in here. You can see that the value dev.in28minutes.com is being picked up from application-dev.properties. Similar to that, you can see other things in here as well. If you go to actuator/env, this is the environment endpoint. The environment endpoint shows you all the details about the environment. We are making use of port 8080. We are making use of Java 17. You see the specific encoding which is making. You can see the encoding which is being made use of. You can see the class path which is configured for our application. And you can see a lot more details about the environment where we are running in here. So you'll see information about Java, JVM, Tomcat, everything would be present in here. Now, the last one which we'll explore is something called metrics. If you scroll down, you should see this localhost 8080 Actuator metrics. If you open it up, you should see a list of metrics which come back. You can see application started time, disk free space, total space. You can see details about you can see metrics around the executor pool. You can see a number of metrics related to JVM in here as well. What I'll do is I'll look at a specific metric, HTTP server.requests. So I'll copy this, put a slash and type in HTTP server requests. You can see all the metrics around HTTP server requests in here. You can see that right now, the count of requests is 8. The total time of execution to handle those requests is this much. And the max to handle a specific request is 0.020 seconds. Now let's go to Actuator, fire this URL a few times. I'm refreshing this page about 10 times. And let's go back to Actuator metrics and refresh that specific HTTP server request metric. You can see that the count of requests has increased. So it's tracking the number of requests which are coming in to your application. So Actuator provides you with a lot of information about your application and the environment in which your application is running. You can get a lot of metrics about your application, and you will be able to also get a lot of metrics around the Java runtime or the JVM and the Tomcat server where your application is running in. One of the important things to remember about Actuator is that whenever you enable a lot of endpoints, you are gathering that information. And gathering a lot of information means more CPU and more memory. Typically, you need to explicitly configure the endpoints you would want to include. So for example, I can configure health, metrics. These are the only ones which I'm making use of, for example. So I'll enable them. And if you go back to the actuator, you should see that there are only these endpoints which are exposed right now, health and metrics. In this step, we looked at monitoring your application in production. The feature in Spring Boot that you can make use of is Spring Boot Actuator. In the last few steps, we understood some of the important features of Spring Boot. In this step, let's compare Spring Boot versus Spring MVC versus Spring Framework. Spring Framework is all about dependency injection. It's about defining the dependencies, identifying the dependencies, and auto-wiring them in. You can define dependencies using a variety of annotations, add component, add service, and there are a lot of others. Once you have defined your dependencies, you need to identify them. That's where component scan is useful. You can do a component scan on a specific package and identify all the components which are defined in there. Once you have all the components and their dependencies identified, you can auto-wire them together. That's the core work of Spring Framework. However, just dependency injection is not sufficient to build great applications. You need other frameworks. If I would need to talk to a database, I would need Hibernate or JPA. If I would want to write a unit test, I would need JUnit and Mockito. Spring modules and Spring projects extend the Spring ecosystem. They provide really good integration with other frameworks. So if you want to talk to a database, Spring provides really good integration with Hibernate and JPA. If you want to write a unit test, Spring also provides good integration with JUnit and Mockito. So the core of Spring Framework is dependency injection, and Spring modules and Spring projects help you to extend the Spring ecosystem and integrate easily with other frameworks. Now, what is Spring MVC? Spring MVC is a Spring module. The focus of Spring MVC is on simplifying building of web applications and REST API. It only focuses on web apps and REST API. Before Spring MVC, the most popular framework was struts. Building web applications with struts was very complex. There was a lot of tight coupling which was involved. However, Spring MVC provided a better approach than struts to build your web applications. With Spring MVC, you can make use of annotations like add controller, add REST controller, add request mapping. These are all the things that are defined as part of Spring MVC. Earlier, when we built the REST API, we made use of add REST controller and request mapping. So the core of Spring Framework is dependency injection. Spring MVC helps you to build web applications. As we evolved with Spring Framework and Spring MVC, we saw that there is a lot of configuration that is needed in your pom.xml, in your web.xml, in your application context.xml, whenever you'd want to build even a simple application with Spring and Spring MVC. And that's where Spring Boot comes in. Spring Boot is a Spring project. As we discussed earlier, the goal is to help you build production-ready applications quickly. The key features of Spring Boot are starter projects and auto configuration. If you want to develop a web application, the web starter would bring in all the dependencies that are needed. And auto configuration would eliminate the need to set up Spring MVC and other frameworks. It automatically provides a default configuration based on whatever is in your class path. In addition, Spring Boot also enables a number of non-functional requirements. If you want to monitor your application, you have Actuator. Embedded servers simplifies the deployment of your applications. And Spring Boot also provides default logging and error handling. We also saw that Spring Boot simplifies application configuration through profiles and configuration properties. In this step, we understood Spring Boot versus Spring MVC versus Spring. As you have understood by now, Spring Boot is not a competitor to Spring MVC or Spring. Spring Boot is just a wrapper that makes it easy to use Spring MVC and Spring. I'm sure you're having a wonderful time, and I'll see you in the next step. Welcome back. I'm sure you had an incredible time in this specific section. The goal of this section was to give you a 10,000 feet overview of Spring Boot. We wanted to help you understand the important terminology around Spring Boot, starter projects, auto configuration, actuator, dev tools, and we also wanted to help you understand the advantages of Spring Boot. Spring Boot helps you to get started quickly with production ready features. I'm sure all the knowledge that you have gained until now will be really, really useful as we build more features going forward. I'll see you in the next section. Let's now think about one very, very important question. What are the different things that a Java developer has to learn to call himself a great developer today? He needs to understand the fundamentals of Spring Framework, dependency injection, inversion of control, how to create a Spring container, how to manage beans using Spring Framework. He needs to understand Spring Boot. Spring Boot makes it very, very easy to make use of the Spring Framework. If you can do something with Spring Framework using 1000 lines of code, in Spring Boot, you can do the same thing with 500 lines of code. So Spring Boot makes using Spring Framework really, really easy. So you need to understand the fundamentals of Spring Framework. You need to understand how to save data to the database. Spring Data JPA, Hibernate, JPA, these are all the things that you need to understand. After that, you need to also understand other Spring modules like Spring AOP, Spring JDBC, and a few others. Knowing the frameworks is not sufficient. You need to know how to build applications. You need to know how to build a web application. You need to understand what is REST. You need to understand how to build a REST API. And you also need to understand what are the REST API best practices. And today, it's also expected that you are a full stack developer. React is one of the most popular front-end frameworks. So having good knowledge of React and how to connect it with a Spring Boot backend will be a great add-on. You'll also need to be good at writing great unit tests. In addition, you need to know how to containerize your application. You need to know how to build a container image and run containers. And cloud is everywhere today. You need to know how to deploy your applications to the cloud. So whether you're building a web application, a REST API, a full stack application, you need to know how to containerize it and you need to know how to deploy it to the cloud, for example, AWS. As you can see, there are a lot of things that you would need to learn to be a great Java developer today. Earlier, in 28 minutes had almost 10 courses where we covered these aspects in depth. What we found is that developers found it really, really difficult to navigate through all these courses. And that's why we decided to make it very, very easy for you. We have launched an amazing course which covers all these features in just one course. So in just one course, you will understand the fundamentals of Spring Framework, Spring Boot, Hibernate, JPA, Spring Data. You will understand some of the important Spring modules out there. And you will learn to build several applications, web applications, REST API, full stack application. And you will also learn how to containerize them. And you'll learn the fundamentals of one of the cloud platforms, which is AWS. And you'll deploy all these applications to AWS. Isn't that awesome? Our goal with this course is to make it very, very easy for Java developers to become great Java developers. The conceptualization and creation of this course took about a couple of years. I'm sure you'd love it. Go ahead and check it out right now. I'm sure you're having a great learning experience. And until I see you again, here's bye from Ranga at in 28 minutes.